Welcome back to our college algebra notes. We're on Unit 3, Outcome 3. Last time we introduced exponential functions. We saw that exponential functions have a real whole number positive base, or not whole number, positive base. So they're like the b to the x things where the power x had to be real, and it could be any number you want basically. But the base had just to be a positive number. And we said those were one-to-one functions. We graphed them and saw that they did pass the horizontal line test. So this time, the idea of this section of notes is to talk about the inverse of these exponential functions. So an exponential function looks like this, where b is a positive number other than 1. And if we want to find the inverse, well, remember the way we find the inverse is, first off, we're going to write this as y. So we'll just write this with y equals, because that makes it a little bit easier to solve if we have y there instead of f of x. And then we switch x and y, right? That was the big trick when trying to find the inverse, is we just switch the x and y. If you flip those around, so this becomes x equals b to the y, then you actually have the inverse function. Now, most of the time we would look at this and we'd say, okay, well, now solve for y, because we like to have our functions solve for y so that when you plug in x, you get y as a result. The problem is when you go to solve this equation for y, we don't have any way of solving for a power. There's no way to get rid of this power. You might think about like the y root. I know I always have someone say, what about taking the root? Well, if you try and take the root of this, like the y root, then you don't get y by itself. You actually get y inside the root around the x. It's just not nice. So taking roots doesn't work because it doesn't solve for y. There's no way that we've covered so far on how to do this. We don't have a method for this. So this inverse of the exponential function doesn't have a nice way to solve it. So mathematicians over time said, okay, we need a function that if you plug in x, you get a y for this equation. So a function that, if you plug in x, you get a y. So this function is going to give us the number y, which is the power, on a base b that would give you the result x. So you plug in x and say, okay, I want to get x as my result, and the function will give us back y, the power. And so that function is called the logarithmic function. And so this is the function, the logarithmic function. It is a function that gives you back the power if you give it a certain number, and the power is what power you need to get that result, that number, depending on your base. So we'll write it like this, where y is the power on base b that will give us x. So b to the y will give us x. So this is the exponent form there. This is the function solved for x. But this, using the log equation, the log function, lets us solve it for y. So now we can plug in x and get y as a result. Notice that the base of logs, the base is the same base we had for the exponential function. So the base does have to be positive, has to be bigger than 0, and it can't be 1. So you can never have a base of a log be 1, and it can't be a negative. The base of the log always has to be a positive number other than 1. Also, logs only work for positive numbers because when you take a positive to a power, you have to get a positive result. So since x is going to have to be positive, this is only going to work if x is positive. So logs, you can't take the log of a negative. You can only take logs of positives. So it only works on positive numbers. So it's kind of like the square root numbers, right? You can't square root a negative. I know we had the imaginary numbers, and that made it okay. But if you go back to the beginning of this semester where we said, okay, we're not going to worry about imaginary numbers, we said we can't square root negative numbers. Same thing with logs. You can't take the log of a negative number, and there are no imaginary numbers for logs. So logs will never work on a negative number. There's nothing that makes them work that way. Okay, a couple big basic functions for logs. So these are big basic properties that you need to know about logs. First off, if you have log base b and you take that log base b of b, where the base and the number match, the answer is always going to be 1. That's because 1 is the power. Remember, the answer to a log is your power. 1 is the power on b that will give us b, right? So b to the first is b. So because that's true, this is the power we get if we're trying to get b for an answer. Well, we need a 1 power because b to the first will keep it b. So if the base and the number match, it just simplifies to 1. It just solves and gives you 1. Also, log base b of 1. So if you take the log of 1, no matter what the base is, you always get 0. Because 0 is the power that you take b to if you want to get 1. Remember that b, any number to the 0 power is always going to be 1. So if you're trying to get 1 for your result, then 0 is the power that's going to get you that. Remember, the answer to a log is always the power, so the 0 power will get us a 1. So the first power will keep our b. So some logs, you can just look at them and you should be able to just solve them right away using these nice properties. For example, log base 6 of 6 is just 1, right? Because 6 to the first will give us 6, right? So if I take that base 6 to that first power, it'll stay 6. That's why, because of this, the answer is 1. So that's our answer for that one. Here we have log base 5 of 1. It really doesn't matter what the base is because we took log of 1. And the answer, if you're trying to get 1, the power is always 0. So this is saying take your base 5, and what power do I raise it to get 1? Well, you raise it to the 0 power. The power 0 is what's going to give us a 1. So if any log of 1, the answer is always going to be 0. So that's two common properties of logs. You know, if someone shows you something where the base and the number match, you should know the answer is just 1. And if they take log of 1, doesn't matter what base it is, if it's log of 1, the answer is always 0. Okay, now one of the big things we'll do with logs is we'll actually go back and forth between the log form and the exponential form. They're both handy to be able to work with, but a lot of times we actually can deal with an equation with a log and stuff just by rewriting it as an exponential. Sometimes people are just more comfortable with this exponential form. Sometimes it just makes it easier to solve for. But again, the problem with this form is it's solved for x, not solved for y. So sometimes people want it written like this because you want it solved for y. So we'll go back and forth between the two. So first off, we're going to take expressions that are in log form, they have a log in them, and then write them in this exponential form. Now to do this, we're going to look at this, we're going to think about, okay, what is the base, the exponent, and the result? That's what you need for the exponential form. The base is probably the easiest part because the base of this exponential part is always the same base as the base of your log. So this base 2, that is your base. So 2 is the base because it's the base of the log. And then we want to know what power to put on that 2. Well, the answer to your log is always your power, right? Logs give you powers. So the power I want is a 3. And then what result is that going to give me? Well, it's going to give you the result 8, because when you do a log, the number you're putting here is the result you're trying to get. You're trying to get an x. From that base to some power, you're trying to get x. So we're trying to get 8. And you can double check this, right? Because 2 to the third does give me 8. So again, this is your base. This is your exponent, or power. And this is the result that you're going to get out. Just like this is your base. This is your exponent. And this is your result. So that's what you're looking for. So this is an exponential form now. This is written as something with a power. So exponential form, these two equations stay the same thing. They both say that if you start with a 2 base and you raise it to a 3 power, you get 8 as a result. It's just this one, the result is the answer. This one, the answer is the power you needed to get there. So the power that gets me to that result. Let's try another one. So negative 4 equals log base 5 of 1 over 625. So again, the answer to a log is always your power. So I'm going to have negative 4 as my exponent. What's my base going to be? Well, the base is the base of the log. So the base here is the base of the log. That's the 5. So 5 to the negative 4th, because this is my exponent, that's my base. 5 to the negative 4th should give me some result. Well, it should give me 1 over 625. So 1 over 625 is the result I should get. That is the exponential form. My base, my exponent, my result. And you can look at this, you can see that the negative is going to put the number on the bottom. That's why it becomes a fraction. And 5 to the 4th does give us 625. So yes, 5 to the negative 4th is 1 over 625. That's why log base 5 of 1 over 625 says, what power do I put on this base to get this result? The answer is you're going to put a negative power on it, because the negative power is going to give you a fraction. And you're going to put the 4th power, because 5 to the 4th is going to give you the 625. So the answer is negative 4. So logs are weird, because with square roots, we said, you can't take the square root of a negative, and you can't get a negative out of the square root. Well, logs, you can't take the log of a negative. Logs do not work on negatives. But logs can give you negative answers. So it is possible for a log to give you a negative result, and that's okay. So logs have negative answers, but you can't put a negative in a log. That's kind of where you draw the line. Let's try one more. Now again, this number over here, this is what you're taking the log of. So I'm taking log base 10 of 100,000. It's the result you're trying to get to in exponential form. So this 100,000 is going to be the result we're trying to get. And I'm going to think, okay, we start off with the base. So we're starting with base 10. And you think, what power on this base will get us this result? And the answer ends up being 5, right? 10 to the 5th power. 10 to the 5th is 100,000. You do 10 times 10 5 times, you end up with 100,000. So that's what this is saying, that that's the result you want to get. This is the base you're starting with, and this is the power on that base to get you there. Oops, there you go. That's our exponential form. Ignore that. The line there, it's not supposed to be there. Okay, 10 to the 5th equals 100,000. This is exponential form. So we're writing it with an exponent instead of with a log. Okay, that's one way. Let's go ahead and go backwards. So if we can take a log form and put it in exponential form, we should be able to go the other way around. So if I give you something that's in exponential form, you should be able to go back and write it in log form. Of course, if we're going to have to write in log form, we're definitely going to use a log. So we'll use the log function. Now, log function, you always have to figure out what the base is. So in this case, the base of this log is 3, right? Because the base of your exponent part, that base there, that base, is the base of your log. So this is going to be log base 3. I'm going to write this as a subscript, log base 3 with a little subscript. So this is just what kind of log it is. It's like when you do a square root versus a cube root. You have to put the little 3 there to tell that it's a cube root, or 4 tells it's a 4th root. So this 3 here tells everybody this is a log base 3. This is a base 3 log. So it's working from 3 to its starting point. And then we take log base 3 of the result. So we're trying to get 81. So log base 3 of 81 gives us our answer. And then what result is this going to give us? Well, the log is going to give us the power, right? It's going to tell us what power we put on 3 to get 81. And the answer is the 4th power, because 3 to the 4th will give us 81. So base 3, we're going to put a 4th power on it. And that's how we're going to get 81. That's our answer. So this is log form. The result is your power. The base is the base, right? It's the number that has a power. And then this 81, that's what we're taking log base 3 of. We're taking log base 3 of 81. Okay, let's try another one. Okay, again, you're going to have a log. And you know that the answer to your log is always the power. So right off the bat, I know the 3 is the power. That's what the logs are going to give me. Logs are going to give you powers. You need to label the log. So what base does it have? Well, the base here is 5, right? That's the base. This is 5. And we're taking log base 5 of 125. So 125 is what we're taking the log base 5 of. So we're saying, okay, log base 5 of 125. So what power on 5 gives us 125? Well, 5 to the 3rd gives us 125. So that's the answer for that one. That's it. Next one. Write the equation in its equivalent logarithmic form. So again, we're doing a log. We know the base because here the base is e. So e for my base. The number we're taking the base of, the log of, we're taking log of 1 over e. That's what we're trying to get to. So what power do we use to get there? Well, again, the power negative 1 is our power. So e to the negative 1st gives us 1 over e. That's how we get this. This is the base, what you're starting with. What power is going to get us 1 over e? Well, negative 1st power, because the negative 1 will put the e on the bottom. So that's why this works. And e is okay as a base of a log because it is a positive number. It doesn't have to be a nice number. It doesn't have to be 1, 2, 3. It could be things like e, square root of 2, pi. As long as the base is positive, we're happy. That's what we're really just looking for. So the basis logs are always positive. Okay, so that's just going back and forth. You also get some logs, so we're going to be asked to solve the logs. So we're going to try and solve these logs. Now this tells us not to use a calculator because it's good for us to think about how this works, but there's no reason why I would tell you not to use a calculator on the exam. So on the exam, if you want to solve these, you can definitely use a calculator. I'll show you how in a second. Let's do this first without. So if I want to solve this, one thing I like to do is I think about the exponential form. So I think about how the base is 2. The answer to your log is always going to be your power. So I'm looking for this power on that base 2. It will give me 32. So I just need to figure out 2 to what power is 32? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 5 is the power I want, because 2 to the 5th gives me 32. So my answer is 5. So you can see how you don't really need a calculator to do that, because you just have to figure out what power you put on that 2 will give you this 32. But if you want to use a calculator, almost all of your calculators will do this nowadays. Some of the older calculators, if you have like a T83, T82, they might not do this. Every once in a while I see a T84 that's not a plus, or maybe it's a really early version of the T84 plus, and it might not do this, but most of yours should do this. So I'm going to go ahead and show you how to do this. This calculator will do logs. What you do is you hit this log button here. Now you'll notice that the log button doesn't have a base on it, so you hit log and it doesn't do anything with a base. It defaults to base 10, which we'll talk more about later. Just like when we do square roots, you know, the square, the second root's the default. This one, it's base 10. If you want to do a different base, what you do is first you type in the number you're taking the log of. So I'm going to take the 32, because that's what I'm trying to take log of. And then to tell it to do a different base, not base 10, I'm going to do comma and type the base I want. So I'm going to type 2. So this is how you type them in your calculator. You do log of the number, comma, the base. I know if that feels weird to do the base second. It's because, again, when they wrote this calculator, when they made it in the first place, when it was early design and all that, it only did log base 10. Over the years, they made the calculator smarter, it does more. And so now it makes it so it does all kinds of logs. So this one does any log, including log base 2. And so we just have to tell it to do base 2. So you can close the parentheses if you want to, you don't have to, but that's what you do. So you should see how we got 5. If you just did log of 32, you get a different number, because that's the power you'd have to take 10 to. So if I did like log 32 comma 10, you can see I get that same answer. So by default, it's base 10. If you're ever doing log base 10, you can just hit the log button. You don't have to tell the base. But if you want to do something like base 2, you have to type it like that. So on the calculator, I'm going to type log 32 comma 2. So the result that we're trying to get to, then the base. It gives us 5 for the answer. So you have to give it the result you're trying to get to, log of 32, and then the base you want to start from. I want to start with 2, not with 5, not with 10, the default one, and then it'll give you the right answer of 5. Let's try again. This one again. We'll do it without the calculator, and then we'll do it with, excuse me. We'll do it both ways. So first off, if I'm going to do this without the calculator, I'm thinking about my base. My base is 5. The result of a log is the power, so I'm always looking for the power. And I think I want to get 1 over 25. So first I think, okay, I need this to go on the bottom. Anytime you see a fraction like this, you pretty much know you're going to use a negative power, because the negative we'll put on the bottom. Remember that negative power is you just move it to the bottom of the fraction. And then I need to take 5 and get 25. Well, that means I have to square it, right? 5 times 5 is 25. So I'm going to use a negative 2. So the answer to this one is negative 2, because 5 squared is 25, and the negative puts it on the bottom. But again, if you want to do it on the calculator, you would type log of 1 over 25. So 1 over 25 is what we're trying to take the log of. And then we're going to start with base 5. Let's go to do base 5 and see what that gives us. So we do log 1 divided by 25. So I'm going to use just the division symbol. 1 divided by 25, comma 5. And it should give me negative 2, which is the answer. So it does give you negative 2. So again, you can do this without a calculator. You really don't need one for this, but there's no reason you can't use one. So if you're double checking yourself on the homework or the quizzes, just making sure you're doing it right, type in the calculator, see what you get. Okay, one more of these. This one, we're starting with log base 7 of cube root of 7. And this looks all kinds of weird because we've got this cube root of 7, but there's an important thing to remember about this. You should recall that root like this, like the cube root of a number, is the same thing as having that number to a fraction power. This is a thing we've talked about previously in the semester, and something you should have seen before, especially in your previous algebra or math classes, is that a cube root is saying what times itself 3 times. If you do a 1/3 power, you're only 1/3 of the way to getting the 7 by multiplication. So it's the same thing as saying what times itself 3 times will give you 7. So 1/3 power and cube root are equivalent things. So you can actually write this, instead of as log base 7 of cube root of 7, you can write this as log base 7 of 7 to the 1/3. And it looks weird when we do cube root, but when you see 1/3, then it probably makes this problem pretty easy, because you're saying, what power do I put on 7 to get this? And hopefully you see the answer is 1/3. That's the answer. Because if I start with base 7, I say, what power do I put on it to get 7 to the 1/3? Well, then the answer is 1/3, because that's the power that's going to make that look like that. You could do this on the calculator. So again, if you don't want to do this by hand, you could do it on the calculator. You could do log of cube root of 7. So we're going to do cube root of 7, comma 7. To type that in here, I'm going to type the log button. And then you're going to hit the math option and go down to number 4, which is the cube root. So there's your cube root of 7. Get out of the cube root, type comma 7, close it off, and there you go. There's your 1/3. It's a decimal, but you can always hit the math button to turn stuff back into fractions. You just hit enter on the very first option a couple times. It'll turn it back into a fraction for you. So you can see it is 1/3. 0.3 repeating is 1/3. So this does give you 1/3. So just something to note, that if you get a root, cube root, 4th root, 5th root, remember that's equivalent to a fraction power. So cube root is a 3rd power, 4th root is a 4th power, 5th root is a 5th power. Basically the number in the index here is the number that would go along there. We like to throw that in this section on these notes, this homework. They like to throw in these cube roots or 4th roots, 5th roots, because they expect you at this point to know that those are really powers, but you know sometimes people forget. So that's something they'll try and trip you up with a little bit. So you want to make sure you watch for those. Okay, we're getting there. We only have a couple more pages. I mentioned already how logs are usually base 10, and we do have a name for that. We call that the common logarithm. So the base 10 log is called the common logarithm function. And basically, we just write it like this. So if you write a log with no base, it is actually log base 10. And you can write it with base 10. That's totally fine. Just like if you're doing a square root, you could put a 2 in there in the index, and that's okay. It's still correct. It's just most people don't, because if you're doing base 10 logs or doing, second square roots or whatever, people know what you mean if you just don't put the number down. So if you write something like log of 100, everybody should know that this is the same thing as log base 10 of 100. And pretty much everybody, no matter whether you have a TI-83, TI-82, or whatever, should have a calculator to do log base 10. That was like the first thing they made these, big fancy, graphing calculators do, is they made this button for just doing log base 10. So it's really easy for these, let's just type in the calculator, do log of 100 and get a result. So no real reason why you would not use a calculator on this. You definitely can. Everybody's calculator should do that. I know some people's calculators might not do the first option where they do other bases. We'll talk about how you get around that in a minute, on the next page. But everybody's calculator should do log base 10. This is just pretty standard for these graphing, these fancy calculators now, is they almost always do log base 10. And again, you don't have to type the base in, because that's what the default's to. That's why when they write the 10 here, they just put log. They don't put the base on here, because they just expect you to know that plain log like that, plain log, is log base 10. Either way, log base 10 of 100 is 2, right? Because if I think about what's going on, my base is 10. 10 is my base. What power do I need to get 100? The answer is 2, right? 10 to the second power gives you 100. That's why the answer is 2. So you can do it without a calculator pretty easily as well. On the same thing here, want to do log of 1/10. So again, that is the same thing as doing log base 10 of 1/10. So we're thinking 10 to what power gives us 1/10? Well, since the 10 just moved to the bottom, that's it, we want a -1, because the negative will put it on the bottom. So the answer to this one is -1. But again, you can throw it in your calculator if you want to. You can do log of 1 divided by 10, and you get -1. So that one's really easy to do with a calculator. So that's the common log. So any log that doesn't have a base is base 10. That's the rule of thumb. If you don't put a base, it is base 10 log. Yeah. There's actually a second log that is really common, and it is called the natural log. So this is the other log that's super common. This is natural log. Natural log, the big difference with natural log is its base is e. So instead of base 10, it's base e. And we call it the natural logarithm. Now gets a little funny here, because you'd think, oh, it'll be natural log, it'd be NL, and that would be natural log. No, it actually is LN. I think they do this just because then in alphabetical lists and stuff, LN natural log is close to regular log because if you put N in the beginning, they make it move further apart. So I think that's actually the reason. I'm not sure. I haven't really actually done any research, but this stands for natural log. It is LN, and I'll tell you, I've gotten so many students in online classes in the past that didn't know what ln was. They thought it was in, and so they tried to put in my math lab, and it didn't work. You want to make sure you're using lowercase l, because this is natural logarithm. So L for logarithm. It's really hard because a capital I and a lowercase l look the same, and so people get confused. This is a lowercase l for logarithm. So log base e is natural logarithm. That's what it is, log base e. So when you see something like this, ln e to the fifth, this is log base e of e to the fifth. If you write it that way, it's pretty clear that, oh yeah, if I want to put a power on e to get e to the fifth, well, the answer is just going to be 5. And you really don't need a calculator, because e to what power gives you e to the fifth? Well, the answer is the fifth power. And that's pretty straightforward. But again, if you want to do it with a calculator, it's pretty straightforward. The ln button is just down here. In fact, if you're having a hard time remembering which one's which, notice that the blue letters above them tell you which one they are. So log goes 10, natural log is e. That's actually on purpose because these are the inverse functions. So natural log is log base e. This is the exponential function, e to the x. Common log is base 10. This is the exponential function, 10 to the x. This calculator likes to put inverses together. You can see how they have the square root and the squaring function together. Those two are inverses. They put them together. So it does it a lot. So that's why they put those together here. But I like this because it's a way to remember that log is 10 and natural log is e. Again, you can use log for the other logs, but you have to tell it to change the base. Natural log only works for natural logs. If you're using this button, ln, it's because you're taking natural log. So I should just do it real quick. I'll do natural log of second e to the fifth. So that's what we're doing. We're doing natural log of e to the fifth. It'll give me 5. The answer is 5. So same thing down here. We have natural log 1 over e. Notice the same thing as taking log base e, 1 over e. Well, since I just want to move the e to the bottom, this one's just going to be negative 1 again. The answer is negative 1, because e to what power gives me 1 over e? Well, the answer is the negative first power. So that's what the answer is for that one. But again, you can do that in your calculator. You can type in natural log 1 divided by second e. This is a little bit weirder because when you do the e, it needs a power. So this one, just to make it a plain e, I'm just going to put a power of 1, because e the first is just plain old e. And that's how I get my negative 1. So that's how you do that. Okay, last page. Now, some of you have older calculators or an older, I guess maybe have 2 more pages, but second to last page. So you have older calculators that might not work with the whole log of any base. Or maybe you'll Google how to do logs on your calculator online. And what you'll see is people using this property. And this is what people used for a long time before calculators got really smart. What we would do is we just use this what's called the change of base property. And it lets you take any log and change it into a different kind of log. So back in the day, 10, 20, 30 years ago, not even that long ago, it was just even still pretty recently, people, instead of using these calculators that would do any log, would just use a calculator to do log base 10, and they'd take their log that they had and just turn it to log base 10. And if you Google how to solve logs, you'll still see that. You'll see it all over the place on like YouTube and stuff, because it's a really common thing. And so the rule says that if you have a log, you don't like your base. You're like, oh, this base is crap. I want to get rid of one on a different base. You can do that. You can write a new log with a different base. And so the a base here is just whatever you want. And you can pick any base you want. Most of the time people pick base 10 just because that was an easy base. But you pick anything you want. But to do that, it actually turns into 2 logs. It turns into a fraction where you put the old number on top, so the number you were trying to take log of originally, and the old base goes on bottom. This formula is on your formula sheet, and really the only people that will need this at this point are people with older calculators that can't just type this in their modern calculator and get an answer. So if you got the fancy calculator that does the new common logs and stuff, the T84 Plus should, as long as it's kind of up to date and stuff, then this will do it. If you have an older one of them, then maybe not. But if you don't have a nice modern calculator, what people would do with the change of base property, they'd take this expression and they'd rewrite it as two logs. They'd pick a new base, usually base 10 or base e, because those ones are always on your calculator, no matter which calculator you have. Even if you have like a scientific calculator, most of those will have natural log or common log. I'm just going to do this from common log, so base 10. And then you put the old number you're trying to take. I was trying to do log of 25. You put that on top, and the old base on bottom. And that's how they type it in. So instead of having to, mess with the log of base 3, on here, you can use your calculator. You can just do log of 25, close the parentheses, divided by log of 3. And this works always. So if you have a log and you don't want to use the, comma 3, I don't know why you wouldn't. It's pretty straightforward. If you don't want to, you just take log of the number first, divided by log of the base second. And then that gives you the answer. So that's the answer for this one. It is 2.92995, whatever. You probably don't need that many decimal spots. My lab will tell you how many. Or if you want to use the modern calculator, so this is the way I would do it on my calculators now, I would just take and type log 25, comma 3. So log of 25, comma 3. And it gives me the same exact answer. Okay, excuse me. 2.92995. So the only people, like I said, that really need this change of base formula anymore are people with older calculators. The calculator's not smart enough to do this for you. You're really not going to calculate this by hand, so you're going to be using a calculator. The only time you'd need this is if this, like the change of base, is if your calculator is just not that good, doesn't do the any base, and so you have to type it in like this. You can see that's not a big deal. Like this is not that much harder to type in than this. And so if you have a calculator that does logs at all, you can use this method. And it doesn't just work with logs, with common logs. It also works with natural logs. So let's do one more, and we'll do this one with natural logs. I'm going to do natural logs this time. Natural logs. Again, you do the number 8, the number I'm taking the log of first, and the base second. So do the base on the bottom, 1.2 on the bottom. So do natural log of 8 divided by a natural log, 1.2, and that will give us our answer. Answer is 11.4 something. 11.4054. We'll go like that. But again, if you like to use your calculator, you have fancy, nice new calculator like mine, you can just do log of 8, comma 1.2, and I'll give you the exact same answer. So just type log, not the natural log, but log of 8, comma 1.2. You get that same 11.40, blah, blah, blah. So 11.4054. So you're welcome to use either method. I'm never going to make you use change of base method. It's really just there for someone who didn't, get the brand new fanciest calculator. I've had people even with the TI-4 Plus sometimes, they just have an old firmware on theirs because they've been making that calculator for years. And so the first versions of it didn't even do this. Eventually they added just a feature. So this is, this is not a super old thing, but it's something that's ubiquitous now. If you go and do this online in Excel and your computer, stuff like that, you can use this method of doing logs. You don't have to do it with the change of base formula. So that's our change of base formula. Again, it's something we just don't really use anymore because technology is advanced. That's one thing that's kind of crazy about logs. Is it's one of the places where math, where at least the technology is changing, and so how we do it is changing. Okay, last page here. This is the last page. I forgot about this last page for a minute there. Just what logs look like as graphs. So let's look at the graphs of logs. Now on the left side, you'll see these two. This top one here is a exponential function. We actually saw this before, right? These exponential functions get bigger to the right. This was an exponential function when the base is big. Well, because logs are the inverses of exponential functions, you can see there's this nice symmetry where this log function, so this is a log function, is symmetrical with that other function over that diagonal line. So that's true for your log functions. Log functions are the symmetrical or the inverses of your exponential functions. And so that's what they'll look like. So this would be a log that's got a base that's bigger than 1. So if your base is bigger than 1, if you have a big base, so log base 2, log base 3, log base 4, log base 10, those are always going to go up the right. The bigger the number you put in, the bigger the result you'll get out. There'll be increasing functions. Versus if you have a log that has a small number, something between 0 and 1, so like a fraction, like log of base 1/2, log base 1/3, that one is going to look like this. This is the log function if the base is small. So that's log base b to the x when the base is small. So if your base is small, between 0 and 1, so a small fraction, then it goes down to the right. That's going to be the other option. So that's what your two functions can do. Either way, doesn't matter which way you're doing it, the domain of your log is always going to be all positive numbers. So notice the logs only go from here out to the right, like that. There's no value for the logs on the left side. So again, remember that logs don't work on negative numbers. You have to use positives, something from 0 to infinity, for it to work. In fact, you can't even take a log of 0. That's not an option. It has to be bigger than 0. The range, so the range of your logs is all real numbers. So the logs go up and down forever, right? They go up and down forever. The logs go like this, up and down forever. They go down this way, up, down. So logs can give you positive or negative results, but they only work on positive numbers. Last thing, the logs here, they approach but do not touch the y-axis. It does not touch the y-axis, which means that that is a vertical asymptote. So the y-axis, x equals 0, is a vertical asymptote. So this line right here is a vertical asymptote on either version. That's your vertical asymptote. So the horizontal asymptote is for the exponential functions. Log functions have a vertical asymptote. Has to do with that whole inverse thing again, because if you take the exponential function and you flip it over this diagonal line, it's horizontal, so it turns into a vertical asymptote for the log function. So log functions, if they're big numbers, they go up to the right, and small numbers go down to the right. You have a vertical asymptote at 0, and they do not give you, they do not have any inputs in the negatives. You cannot work with a log of a negative. So let's go ahead and graph. Now, a lot of times the homework in the textbooks will have you do both, the exponential and the log, because traditionally, before calculators got too fancy, the way to graph a log was to graph the exponential function and then just graph the log function by doing the inverse. Nowadays, we don't need to do that. You can actually do the log function on your calculator because your calculator is getting fancy. You can do this. You just have to type it in correctly. So to do this on the calculator, what I would do is I would type log. I'm taking log of x, so I type x. And the base I want to have this be base 2. So I'm going to type this to base 2. So back in the day, you couldn't change the base. So we couldn't type this in the calculator, but now you can. So you can just hit graph and see what it looks like. It looks like this. If you want the values of this, you just hit second in the table. And there's values. Notice it doesn't have any values for the negatives, remember, because you can't take log of negatives. But it does have values for like log of 1 is 0, log of 2 is 1, log of 4 is 2. So you can use those points. So you can say log of 1 is 0, log of 2 is 1, log of 4 is 2. So it looks like this. Again, don't have anything between 0 and 1, so. But I do know that this is going to go like this, and that would be log base 2 of x. It does have a vertical asymptote, right? A vertical asymptote right here. That is a vertical asymptote. So we're not even going to bother with 2 to the x. We're just going to go ahead and graph it. We're just graphing log base 2 of x, because we don't need the other one to graph this. Back in the day you did, now we don't. If you don't want to, I could just type it on the calculator, graph it, or I could just remember that, graph by hand like we did last time with the t-chart. But really, now we're just worried about logs. Okay, so that's it for homework 3. So for this set, we're just introducing the idea of these logarithmic functions, how they work. Remember that the log function is something that gives you the power, right? It gives you what power you need to get that base to that certain result. Next section, we're going to talk some more about the different properties of logs. Logs have a lot of pretty cool properties. It makes them really usable. You can do a lot with them. And then later, a couple sections from now, we're actually going to solve equations with logs. That's one of the big things we have left to do in this semester. And then after we're done with logs and exponential functions, we'll move on. And the last thing we're going to do this semester is work with solving equations where you have systems of equations, you have multiple equations and try to solve. So that's going to be a change of pace after we get done with logs. But most of the rest of this unit we'll be dealing with these log functions, these exponential functions. So I'll see you on the next set.